Welcome. Today we're diving into LiDAR, a truly incredible technology that is, quite literally, making the invisible visible and completely changing how we see our world. So let's kick things off with a little thought experiment. Imagine you're trying to find a lost city, one that's been completely swallowed up by a super dense jungle. You can't see the ground, forget about any ancient buildings. So how in the world do you map something you can't even see? Well, the answer isn't to just bring in a bulldozer. Nope. The answer is a revolutionary technology that lets us see through the trees, revealing the world in a way we never thought possible. It's called LiDAR, and that stands for light detection and ranging. It's what's known as an active technology. That means it doesn't just passively look at things. It actively sends out millions of tiny signals, in this case laser pulses, to feel out its surroundings. This is how we start to pull back the curtain on those hidden landscapes. So how does this all actually work? It might sound like magic, but it's really a fascinating blend of physics and some seriously precise timing. The easiest way to think about it is like a bat's echolocation. You know how they send out sound waves to navigate? Well, LiDAR does the exact same thing, but instead of sound, it fires out millions of super-fast laser pulses. The process itself is surprisingly simple, but so powerful. First, the scanner sends out a laser pulse. That pulse travels, hits an object, say a tree branch or the ground, and then a little bit of that light bounces right back. The system then measures the exact time it took for that round trip. Now do that millions of times a second, and you get this massive collection of individual data points that build a crazy detailed 3D map. It's called a point cloud. It's like creating a digital ghost of the landscape. Now, you might be thinking, hey, isn't that just like radar? And you're on the right track. But there's a key difference. While LiDAR uses laser light, radar uses radio waves. That difference gives LiDAR a much, much higher resolution, which is why it can create those incredibly detailed 3D maps. The trade-off? Heavy fog or rain can be a real problem for LiDAR, whereas radar can often just power right through it. And the really cool thing is, this technology isn't just used in one specific way. No way. It operates on hugely different scales, mapping our world from the vastness of space right down to the centimeter level on the ground. I mean, these LiDAR systems can be mounted on just about anything. You've got satellites up in space giving us global elevation data, you have aircraft and drones doing regional surveys, and you even have systems on tripods, cars, and backpacks for unbelievably detailed ground-level scans. So when you combine all the data from all these different platforms, what you're really doing is creating a high-resolution 3D model of our entire planet, what some people are calling a digital twin that we can explore and analyze like never before. Okay, so that's the how. Let's get to the really fun part, the what. Let's look at how this technology is actually being used in the real world to completely transform entire industries. Remember that lost city we talked about at the beginning? Well, this is it. Archaeologists are using LiDAR to literally peer through thick jungle canopies, revealing ancient ruins and entire cities that have been totally hidden from human eyes for centuries. It's incredible. For forestry, LiDAR is a total game changer because some laser pulses bounce off the top of the trees and some make it all the way to the forest floor. Scientists can accurately measure everything from tree height and canopy structure to even estimating a forest's total biomass. And you might actually see LiDAR in action every day without realizing it. It's the eyes for a lot of self-driving cars, creating a real-time 360-degree map of everything around them with centimeter-level accuracy. Utility companies are also putting it to great use. They can use LiDAR to scan hundreds of miles of power lines, spotting potential hazards, like trees growing too close, long before they can cause an outage. And get this, it doesn't even stop at dry land. Special types of blue-green lasers can actually penetrate water, allowing us to map out riverbeds in shallow coastal areas in detail. I mean, this is crucial for flood modeling, for marine biology, the list goes on. Isn't that just wild? As you can see, the impact is just massive, from measuring crop height in agriculture to creating unbelievably precise 3D models of entire cities for urban planning. LiDAR is providing a whole new dimension of data across countless fields. So, with this absolute explosion of 3D data, what does the future actually hold? Where is all of this heading? Well, we're definitely entering what experts are calling the LiDAR big data era. And this isn't just about collecting the data anymore. It's about figuring out how to manage and analyze these enormous 3D datasets that are growing at an unbelievable speed. And even though all of this feels so futuristic, like it just popped up overnight,
The research behind it has actually been developing for over 20 years. All of that foundational work has brought us to this amazing moment of innovation that we're seeing right now. To put it in the words of one leading academic, LiDAR has become an indispensable tool. It's not some niche technology anymore. It's become a fundamental part of how we understand our planet in 3 dimensions. So, this all brings us to one final, really exciting question. Now that we have the power to create a high-resolution digital twin of our entire world, the potential for discovery is just immense. The question is no longer if we can map it all, but what are we going to find when we do?